The introduction to alignment and calibration. Alignment and calibration are essential steps using GNSS combined navigation systems. But let's look at some other concepts first. The origin and X, Y, Z axes of the IMU coordinate system are defined by the IMU manufacturer. For details, please refer to the marks on the outer surface of the box. The origin and X, Y, Z axes of the vehicle coordinate system are defined by Bynav technology. The origin is located at the center of the vehicle's rear axle, the Z-axis points towards the sky, the Y-axis points in the direction of the vehicle's forward movement, and the X-axis is perpendicular to the Y-axis, pointing to the right side of the vehicle. The local navigation coordinate system refers to the ENU coordinate system. The antenna lever arm describes the position of the antenna in the IMU coordinate system, characterized by the three-dimensional distance from the navigation center to the antenna phase center. RBV describes the rotation relationship between the IMU coordinate system and the vehicle coordinate system. Rigid connection refers to a connection method involves no relative displacement. For combined navigation systems, the entire system and antenna should not experience displacement or visible shaking due to vehicle movement. Attitudes refer to the heading, pitch, and roll. Alignment is the process of initializing the attitude of a combined navigation system. It is also the process of physically aligning the IMU with the ENU system. Simply put, it allows the combined navigation system to discern directions such as east, west, south, north, up and down. Since every acceleration and angular velocity result provided by the inertial navigation system depends on the previous acceleration and angular velocity results, the inertial navigation system needs to obtain initial direction through GNSS or other means every time it is powered on. This allows the system to determine its true attitudes within the local navigation coordinate system, which is to complete alignment. Combined navigation systems with dual antennas can directly obtain direction through dual antenna orientation, so course alignment can be completed while stationary. In contrast, combined navigation systems with a single antenna can only obtain direction by moving and then complete course alignment. To improve alignment accuracy and quickly complete subsequent calibration, it is also necessary to get correction data, so the combined navigation system can enter the fine alignment mode. After the GNSS/INS combined navigation system is installed, it is difficult to ensure that the IMU coordinate system and the vehicle coordinate system's axes are perfectly aligned. Calibration is the process of minimizing this axis misalignment to improve the accuracy of attitude and positioning. As long as the GNSS/INS combined navigation system is not relocated, calibration only needs to be completed once after proper installation. The greater the deviation between the set value and the actual value of RBV is, the more time the combined navigation system will spend correcting this deviation, and the greater the difficulty will be. When the deviation exceeds a certain range, the combined navigation system may not be able to complete calibration, or the calibration results may be poor. That means the coincidence between the axes of the IMU coordinate system and the vehicle coordinate system is low, leading to decreased accuracy during attitude transformation and dead reckoning. So, please ensure that the set value and actual value of RBV are close before calibrating, and that the combined navigation system has reached fine alignment. Next, a brief introduction to the operations related to alignment and calibration will be provided. For detailed instructions and help, please refer to the introduction videos for each product. GNSS/INS combined navigation systems should maintain a rigid connection with the vehicle and are recommended to be installed with the Y-axis pointing towards the vehicle's forward direction, the X-axis pointing to the right side of the vehicle, and the Z-axis pointing towards the sky. For dual antenna products, it is recommended to arrange both high-precision GNSS antennas along the direction of vehicle movement, with a recommended distance of not less than 1 meter between the two antennas. You can obtain the upper computer software by connect from the official website of Bynav for configuration. Set the output messages as shown in the video. Then, in the RTCM config module of Connect, enter the relevant information of the trip service. If the product is installed with the Y-axis pointing towards the vehicle's forward direction, the X-axis pointing to the right side of the vehicle, and the Z-axis pointing towards the sky, you can directly send the commands shown in the video. If not installed in the recommended manner, RBV values need to be set according to the actual situation. At this time, you can use the ByOffset module in ByConnect to calculate and configure RBV. Then, as shown in the diagram, use tools such as a tape measure to obtain the 3 measurement values of X, Y, and Z, and put them in the command, then send the command to enable and save the configuration. After completing the aforementioned configuration, if correction data input is still maintained and the antenna is in an open space, dual antenna products will usually complete course alignment automatically while stationary without additional operations. Single antenna products require the vehicle to complete straight line and turning maneuvers. You can know the status by the indicator lights in the lower right corner of ByConnect. When the first 2 indicator lights turn green and the third one turns yellow, the combined navigation system has completed course alignment. Then, please select an open straight road where the vehicle can turn around, with a flat road surface and a length of not less than 1 kilometer. Drive back and forth on this road at a speed of not less than 18 kilometers per hour. When the third indicator light in the lower right corner of ByConnect turns green, the device has reached a fine alignment state. At this time, enter and send the commands shown in the video in the command input box of ByConnect. Then, keep driving and pay attention to the source status field in the install status message. When the content of this field becomes calibrated, it means that the calibration is complete. Record the offset values of the X, Y, and Z axes at this time. Then send the command saveconfig and reboot to save the calibration results and restart the device to make it effective. After the restart is completed, send the command log insconfig once. Confirm that the RBV offset is consistent with the X, Y, and Z axis offsets recorded in the previous step. If they are not consistent, you need to fill the recorded 3-axis offset values into the command in the aforementioned steps and manually send the command to set RBV. Thus, the alignment and calibration of the combined navigation system are completed.